All right, so online, y'all should be able to see my board now. All right, so to plan today, we'll knock out 2.3. It's a pretty small section, and then get a good start on 2.4. All right, so first one in 2.3, this is finding domain range. I think Cameron was doing something weird there. All right, so the first one, I'm going to draw a graph and go through what these questions it's going to ask. All right, so I'll go about 5. All right, so y'all got points over here at -1, 1, -2, 2, -3, 3. And on the right side, I got a point at 0, 2, 1, 3. And then let me get these last points. I got one at 2, 4. And then one at -4, 4. So it sort of makes a little V there. So they got 4 questions they want me to find on this, okay? So they got an A, B, C, and D. So for A, they want us to find f of -3. So notice, they didn't give me an equation, so they want me to know what that actually means. Remember, f of -3 wants me to find the value if I put a -3 in for that x. So to answer this one, you want to find -3 on that x-axis and tell me what that y value is going to be. Oh, what's that thing?
Martinez.
Yeah.
I got lost. I had my GPS on.
There you go. So to find f of -3, we'll come over here, find -3 on the x-axis, and shoot right up and see what that point's giving me. And that looks like that's giving me a +3. So to find function values, you just go find that x and go up to that y value and see what that y value is going to be, okay? Next, they want the domain. Now on the domain, they'll give you the parentheses to put it into. All you gotta actually do is put those values in there. So remember, my domain is my x values. So I need to go see what all the x values are for my points. And really order don't matter, but usually in their answers, they're gonna go left to right on those numbers, okay? So for my domain, I would start out here with -4. -3 would be the next x value, -2, -1, I got a 0 there. That goes to 1, and then that goes to 2. So domain is just all those x values, okay? And like I said, they'll give y'all the fancy little parentheses. All y'all got to do is put your numbers and the commas in there. All right, so here's the tricky one that usually gets people. For C, I want any x values for which f of x equals 2. So to me, this question is almost the opposite of this question. On this question, they gave me the x value and I was looking for the y value. This question, if you notice, they're giving me the y value and they want me to find those x values. So you just want to find me any x values that have a y value of 2. So here's my y value of 2 cutting across here. So 2, I got this point and that point, right? So this would be, I think, what did they put in there? They put x equals, and then you just put any of them numbers in there. So if I'm going left to right, this x value was what, -2, comma, I got a new one sitting right here on the y-axis, which means this x value has to definitely be a 0. Okay? So notice A, they gave me the x, I found the y. C, they gave me the y, we found the x's, okay? So then the last thing they want us to find is the range. What's that last name?
Walker.
And now, just like I did on the domain, they're going to give you the fancy parentheses. Oh, I guess I need it equals. So now we want the range values, which is my y values. So if you're going left, this is what, a 4? Or you can even go up to down. It don't matter on these, okay? I'm just going to sort of go top down, but you could go the bottom and up. Don't matter on that. So I got a 4, 3, 2, 1. And that's the smallest y value I got is that 1 right there, right? But notice here I got another 2. Do I need to write that again? No, I've already got 2 in there. I've already got this 3 in there, and I've already got the 4 in there. So since that other half is basically repeats, we only need it in there once. So I'm going to close my parentheses. So on my range, I should have 4 numbers. Okay. So you're going to have questions on that. So basically, they just want you to get used to being able to read the graph and know what the values are giving you. Okay. Domain was all the x values of the points. The range was all the y values of my points. Okay. So let me do one more of these. We'll do this one with a actual line graph type thing on it, okay? But it pretty much asks me the same questions. So let's draw this one. So that can go down a little further. All right, y'all, right here at the 5, I got a point right on that 5 on the x-axis. And then this sort of just shoots off to the right and to the left. So those you don't have to be exactly where I'm at on that. Just make sure we're at 5, 0 on that x-axis. So for A, they want me to find f of 2. We're gonna be a little tricky on my graph, but let's see. Here's my 2, right? So f of 2 should be at 1, 2, 3 here. So f of 2 for me would be right here. So the y value I get is a
3.
3. There you go. That means f of 2 is definitely a 3. Now in your homework, you'll be able to sort of see it better because you can zoom them graphs up if you need to and actually follow that point right there. So look at this. I got a graph that's going forever to the right. That's what the arrows mean, right? This thing's going forever to the left. So we're looking at the domain on this, right?
So we put infinity to infinity, or negative infinity to positive.
So in about a month, that's what we'll use as interval notation. But for this section, instead of using the infinities at this point, they do the domain is all real numbers.
And that'll be a multiple choice option.
You'll have like an A, B, C, D, and one will have less than, greater than, and stuff like that, and then you'll have the domain is all real numbers. Okay? Which means whatever function they're using to graph this, don't matter what numbers I put in, I'm going to get an answer out of that thing. Okay? C wants to know any x values for which f of x equals 1. Which means here's my 1 on the y-axis, so let me see, I'm hitting it right here, and then right there. So since 1's basically pulling across, I'm going to use what? 4 and 4 and 6. So that would be x equals 4, comma 6, okay? And then D wants to know my range. So be careful on the range. Because although my x's go from negative infinity basically to positive infinity, my y values don't. So the way they do this, they're going to give you the fancy little parentheses again. And they put y in it. So what this means is the variable y is what we're looking at. That bar means such that well, what conditions do I know for my y values? The smallest y value looks like it's sitting right at 0. Because remember, the x-axis is 0 for the y's. And then anything above that. So it looks like anything that is what? Equal to or greater than 0. Let's see, here's my range. And we're going up. Okay. So you would put y has to be greater than or equal to 0. Now later on, that'll be what? 0 to positive infinity, right? So they break that out about, I think it's what we did, chapter 5 or so. So questions on that? So let's get into the gist of what today's about. Finding the domain of a function. Let's walk the graph drawing for a little bit, okay? So finding the domain of a function. There are only 2 things I'm worried about on the domain, and we're only going to look at one of them in this section. The other one we won't get until we're in chapter 6, and that deals with radicals. Because if you remember on a radical, like a square root, you can't take square roots of negative numbers. Those will give me imaginary type answers. So that's one of the things we can't have in our domain. Second thing was the fractions. Okay? So the domain of a function is all real numbers unless we have a fraction with a variable in the denominator. Okay, so last name? Weeks. LEA. All right, so when I'm looking at functions, if I got a fraction in that function, I'm worried about it because there's not a possibility that I can put every number in there and get something out of that. So if you had something like 8 divided by 0, that's going to be undefined. And you cannot graph undefined on the graph. There's no place that says undefined. So if we have a variable in the bottom of our denominator, what we got to do is set the denominator equal to 0. Any solutions we get, we're going to exclude from the domain. Exclude any solutions from the domain. Okay, so that is basically going to look something like this. Okay, so on these answers, our answers will look like curly parentheses. We'll list our variable such that x has to be a real number. And then you would put the condition. So what I mean, say I solved this and I got x could not be a 0, right? So my answer would be x such that x is a real number and x is not equal to 0. Okay? So you use the equal signs, not equal signs. It might be greater than, less than, or other way around, okay? I will say when you're dealing with fractions, you're going to be using the not equals. Later in life, when we get into the radicals, that's where we'll use the greater than and the less than type stuff. But y'all notice the main thing. Unless you have a fraction, the domain is definitely going to be all real numbers. If I got a linear equation, 3x plus 2, I can put any number in for that x, multiply by that 3, and add 2 to it. Okay? Even if they're squaring numbers, I can take any number and square it. Okay? But what I cannot do is divide by that 0. So if you got the bottom of a fraction and it equals 0, you got to kick that out of there. Okay? All right, so here we go. Now I will say in this section, they're not hitting me with the x squared yet. And if I get x squared on the bottom of them fractions, that means I'm going to be kicking out 2 numbers. Right, when y'all have factored stuff, you got 2 different factors. So later in life, we will be kicking out 2, even 3 numbers. Okay, so the biggest exponent really tells you how many numbers you're going to kick out. So if I got an x3 down there, I'm going to be kicking out 3 numbers. Okay. All right, so what you're going to do for these is find the domain of the function. And it just give you a few of these. So I will start out, these start out about number 3 for y'all. So I got f of x equals 13 over x minus 5. So I am worried about that one because it does look like a fraction right there, right? So it's possible that there's a number I can put in for that x to make this thing undefined. So what I do is I take that bottom, and I know the bottom cannot equal 0 for me. Now you can use regular equals on these if you want to, because you're just really solving it for that x. So on this one, I'm basically doing what? Add 5 to both sides. And this is telling me that x cannot equal a positive 5. So that's the only number I'm worried about on this function, right? So for our answer, we'll come in and say x such that x is a real number. So notice the difference. If I didn't have no number to kick out, it would just be all real numbers. So, but x still has to be a real number. So x is a real number. And x cannot equal 5. There you go. Because 5 will make it equal 0, okay? So that's all you're doing. Just take that bottom, set it, and go. Get that one number. Because remember, in this section, it's going to be just one number because we're not hitting with the squares yet, okay? It was when they gonna have a month off for Christmas. You know, come back a little rusty, right? We'll get you going. How about this? P of x equals 2x minus 5. Hey, also 2x minus 5. What y'all doing to that?
Plus 5.
Well, you could, but what do you not see though? Well, I don't have a fraction there, do I?
No.
So remember what we say, the domain of a function is all real numbers unless we have a fraction. Hell, I don't see no fraction. So any number you can come up with that's a real number, I can put it in there, multiply by 2, subtract 5, and still have a real number. So there's no way I'm going to get anything that's undefined, right? So this one is, well, let me see how they put it in here. Yeah, they're just doing it like this. X such that x is a real number.
What section is this?
2, 3. It is mainly just wanting y'all to get good at doing this little bit of domain stuff I'm doing. If you like algebra, that'd be 2.4 that we start on in a second. All right, so I'm going to toughen it up a little bit. So this would be like a 5. P of x equals x squared plus 9. So I ain't really worried about that one. But I don't see no fractions still, do y'all? So since there's no fractions, I'm gonna put
X such that, right?
Hmm.
That bottom is such that,
oh, excuse me.
such that,
So you good, Lee?
so that bar,
Mhm.
such that.
Such that. Mhm. Have you ever worried about there to bar on your computer over there by the enter button or something? They call it a pipe. That's what that means. Such that. Right, but I'm not worried about any numbers I can put into that, am I?
Yeah.
So x,
Hearing it right.
x is a real number. All right, put the line on that. All right, let's do the little bars. H of x equals absolute value of x minus 5. So, no fractions. So once again, since I do not have a fraction, my domain will be the same as I've been putting on the other three, right? X such that x is a real number. Hang on, g of x equals 2 over 7 minus 8x. So if you notice this one, I'm a little bit worried about because I do have a fraction. So notice, the only ones I messed with at all were my fractions, okay? So since I got a fraction, I got to take that bottom, 7 minus 8x, and I know it cannot equal 0. So now, what y'all want to do to solve that? Things subtract that over to both sides, right? And really, you could have moved either one of those. I'd have been happy with either one of those, okay? So this gives me a negative 8x cannot equal negative 7. Because if that equaled that 7, see, that would make that a 0, 7 minus 7, right? Right, next I'll divide by the negative 8. So that x cannot equal, so y'all watch out, all the negatives are going to make that all positive, right? So that x cannot equal a positive 7 8. Say again?
Can you reset it?
Oh, since I have my two negatives, remember like signs on division, if you got two negatives, it's going to make it a positive. All right, so let's see how we would write that. Pretty much the same. X such that x is a real number. So x is a real number. And x cannot equal 7 eighths. Okay, so you're not doing that. There's like 8 problems in that section, I think. The last 6 are doing this. If you got a fraction, you're worried about it. You're going to have to find one of those numbers to kick out. But if you don't have a fraction, it's going to work for all real numbers, no matter what. Okay? Actually, I don't know if y'all remember this from your past, but when a graph is being drawn and you hit a place where it's undefined, usually it makes a hole in the graph, or it might make what we call an asymptote. So it's been a while, right? So when we in chapter 5, I think it is, we're learning all about the asymptotes. They look like funny lines. One goes like this, and then one might come up like that or something. And they make like an imaginary line down, but we don't have to worry about them right now, okay? All right, so that was 2-3. We're about to get into the fun one.
Do you have any batteries? Batteries?
Tablet batteries? When we're in the last part, I can probably go find some. All right, y'all, so here comes the algebra. So let's see, I'm going to start 2.4 right here. And it's actually called the algebra of functions. So given f of x and g of x. So they're just giving me two functions. F plus g of x equals f of x plus g of x. So the sum of two functions is the sum of the two functions, right? F minus g of x will equal your f of x minus your g of x. So those two operations, I get more mistakes on the subtraction because when you subtract functions, a lot of people forget to distribute the negative through the parentheses, and that sort of messes y'all up a little bit. F times g of x is going to equal f of x times g of x. So multiply the two functions. That's where you're going to be doing the distributive property. You might do a little foiling. Y'all remember that stuff, right? First, outer, inner, last. All right, then we got division. F divided by g of x equals f of x divided by g of x. But we do know one thing. G of x cannot equal what? Oh, we just did it on our domains.
Fraction.
But why couldn't it be a fraction? What could the bottom not be?
0.
Zero. Right, if that equals 0 on the bottom, that'd make that undefined, and I wouldn't have a function at all there, okay? So make sure, anytime you're given fractions and stuff like this, I always want to let you know, hey, that bottom cannot be 0, okay?
So it can be a fraction.
It can be a fraction, you just can't have a 0 on the bottom.
Oh,
Okay. So mainly this is going to go over stuff you've learned about adding like terms, subtracting like terms, foiling and distributing, and then canceling. If you've ever canceled rational expressions, a lot of times you factored and cancel stuff out and all that fun stuff. All right, so here we go. So number one, given f of x equals x squared plus 2, g of x is going to equal x plus 3. They want me to find f plus g of x. Now, I will say this, when I put my functions in on my first step, I basically put them in those parentheses. So I want to be able to keep them separated. So f plus g of x is going to equal my f of x plus my g of x. So anytime you first put them in, just throw them in parentheses, just keep them separated. So I know what f of x was. It was x squared plus 2. G of x is x plus 3. Now, this isn't as bad because we're adding. But y'all, if I was subtracting, you would have to distribute that subtraction, okay? So basically, since these are all being added, I can do this. X squared plus 2 plus x plus 3. So when you add, you can just drop in parentheses. So can I do anything to that?
And the whole number.
Number.
So the
So not the x's, but I can add the 2's and the 3. So this would be my like terms. So I would come down with what, an x squared? I'll probably put that x next, and then I got what, 2 plus 3 would give me a 5. Okay. that point, I can't go no further, so I'm done. Not too bad, was it? I got any questions online on that? All right, this one we're given f of x is going to equal x squared minus 4. G of x, x minus 2. They want me to find f times g of x. So now I know what f times g of x is going to equal my f of x times my g of x. So what was I putting in for f? It looks like what, an x squared minus 4. And g was an x minus 2. So, oh boy, I get to do what? Get to spoil this one. So remember, when you multiply x's times x's, you're going to add those exponents, right? So this one don't have an exponent. What you putting there? So that's just going to be what, a 1x right there? So FOIL wants me to take the x squared times the x.
Is it 1x squared?
Well, so what I'm going to do is take that x and then add that 2 and 1 and make that a 3. So altogether, I got 3 x's being multiplied, right? Got the x squared, which was 2 of them, and the other x. So altogether, we got 3 x's. Now, what's this? X squared times a negative 2. Negative 2x squared, right? So when you got a number multiplied by a variable, you just put them together and be done. How about this? Negative 4 times the x. And then I'm going to take that negative 4 times that negative 2. So negative times a negative is definitely going to make that a positive 8. So that brings back memories. Look, to FOIL, you take the first one, distribute through the second parentheses. Then you take the second one, distribute through the second parentheses. First ones, outer ones, inner ones, last ones. Can I do anything else with that? No, because none of them x's match, so I have no like terms, so that's it. So y'all remember, once you get to the point where you have no more like terms, you're done. All right, this one has f of x is x squared minus 3. G of x is going to be x minus 1. So here comes the curve. They want me to find g times g of x. What y'all think they want me to do on that?
Just multiply the g by itself.
That's it, right? They wrote that f of x there, but guess what? I'm not even using it. They just want me to use the g. So g times g would be my g times my g, which we said was what? X minus 1 and x minus 1. So you just write the one that they gave you twice, okay? That's why I say they try to trick you a little bit by actually putting the f in there, okay? So once again, I get to FOIL. So x times x is that x squared. Because remember on that one, since there's no exponents, we'll just add 1 and 1 to make the 2. Then I'm going to take my x times negative 1, so I get a negative 1x. Now, if you like to write the ones, it'll let you write the ones in that line, okay? But remember, if I don't write a number in front of a variable, it's automatically a 1, okay? Now, let's take the -1 and distribute it. -1 times x.
-1.
Then you only got the end, which is a -1 times a -1.
Positive.
Positive 1. Can I go further on that?
Yeah.
Yes.
Definitely. Because I got a lot of nice little x's sitting in the middle. So I guess if y'all can figure out what -1 plus -1 is, we'll be done. I get what, x squared minus 2x plus 1. So remember, when you're adding two negatives, add them and keep that sign. The biggest mistake I get on that is people get my multiplication like signs mixed up with my adding like signs, okay? When you add two negatives, it's still negative. At least that's what my bank tells me. Right? So they'll keep you straight on them kind of numbers. All right, here we go. F of x is going to equal -18x plus 8. G of x is going to equal x squared plus 5. This time, y'all, they want us to find f of 2 plus g of 2. So I wonder what they mean by f of 2 and g of 2.
You set up 2 F's and 2 G's
And-
and solve it.
So you're gonna put these 2's in for the x. There you go. Okay. So here we go. F of 2 plus g of 2 is going to equal my f. Well, let me go down here. My f of 2 plus my g of 2. So that's going to give me f is going to be a -18 times my x plus 8, which y'all said in place of the x, I'm putting a. And then my g of x over here was an x squared plus 5, and I'm also putting in a 2 for that. So I will tell you the truth. They could have said, find me f plus g of 2, right? They could have wrote it all as one big thing and then just put that 2 in there for the x's. So y'all, since we're messing with a lot of parentheses, I'm going to follow order of operations. I'm going to finish this one out, then I'll add them together, okay? So for the first parentheses, you got to multiply first. So a -18 times 2, what did y'all get? -36 plus my 8. Over here, I'm going to square that first. So 2 times 2 is 4. So I get a 4 plus 5. So we're just following our 10 dots inside each one of these parentheses, right? You ever heard that? Please excuse my dear Aunt Sally. Where's she from? Oh, see, high school, they give you most of it, but they don't tell you where she's from. She's from Little Rock, which means go left or right.
Oh.
So y'all go back and fix them in them high school, all right? Because sometimes you can divide before you multiply. You got to go left or right on those, okay? Little Rock's got to be famous for something, yeah.
Put it on there.
So let's see, that -36 and that 8 is definitely going to be a negative something. So it's 36 minus 8. Uh-huh. And then over here, I can add that 4 plus 5, and that'll give me 1 and 9. So I knew since I only had one number, I could now drop them parentheses and get them out of the way. All right, so now -28 plus 9 is definitely a negative something. Okay, there we go. Okay. Those ain't too bad, are they? It's just bringing back all your memories from, we know I've done these before. So I think I got time for one more. F of x is going to equal x squared minus 17. G of x is going to equal 13 minus x. I'm going to find f divided by g of -6. So it looks like we got through most of 2.4 until to get to the end where it starts asking y'all for domains. If y'all want to wait, I'll knock them out Friday. Okay. All right, so look, I got division on this one. So my f divided by g of -6 will equal my my f on top divided by my g on bottom. Now, technically, since I got a fraction, I don't need parentheses because they know that the top is automatically in parentheses. But if you do this on a calculator, you better put parentheses on that top and bottom. The calculator has to know what your denominator is and your numerator, okay? So if you don't put it in parentheses, it'll take this term here and divide by that one, but it won't divide by everything else. It'll just start adding them and subtracting them. It's got to have that stuff in parentheses. Unless you hit the alpha y equals on the calculator, if you hit the green button and then the y equals, it'll bring up fraction. And you can put it in just like a fraction that way, okay? But if, like I said, if you're pushing it in at this straight line, you got to use those parentheses. All right, so top is an x squared minus 7. So that means this is now going to be a -6 squared minus 17. On the bottom was 13 minus x. So 13 minus x, which is a -6. So be careful when you're subtracting negatives because those become positive. All right, y'all, so let me say, we'll work the top. -6 squared becomes a positive 36. So if you square that -6 on the calculator, you better put that in parentheses so it'll square the negative also. And then that's minus 17. The bottom we said was what, 13 plus 6. So that basically is going to give me a 19. So we got to finish out the top. 36 minus 17.
19.
How many?
19.
19?
Yeah.
Oh, so look at that. I'm going to get a 19 divided by 19, which is going to be a big old 1. Okay. So, y'all, that'll leave us a few problems at the end where we got to find domain of these functions. So I will knock that out on Friday on a Zoom. Okay. Any questions online? I don't know how many left online.
No.
So the -6 on there was in the place of x.
So what you basically was doing was taking the f and replacing this x with the -6, and then on the bottom you're replacing that x also with a -6.
These ones we use.
Yeah, you have more than you have here. No. Oh, that's what these big buttons are now, I think.
Yeah.
They're like clinicals. Y'all, they finding that new variant in the US now. They said y'all better start double masking up on y'all.
Oh, yeah.
I get my second shot tomorrow.
Yeah, I get mine like in 2 more weeks.
So
I had to get the Moderna. What did you get?
Pfizer.
So that's only 21 days. Y'all had one. I think mine.
What
was
is
21 days.
everyone?
It's like
Yeah, if you take the Pfizer, you can get it second in 21 days. I took the Moderna one. I got to wait 28 days.
So what?
Now they got new ones. There's like 3 new ones coming out that are single shots. I think you only got to do.
Yeah, but they haven't really tested for variants. Moderna and Pfizer have.
Yeah,
As soon as variants come available, they start testing to see the likelihood.
yeah, I think one where they was talking about that South American or South African variant, we might have to get a booster.
Yeah, but any,
I won't feel like a penny kitchen by the time COVID's gone.
You gonna feel what?
Like a penny kitchen.
you ever get your smallpox?
Well, I had a smallpox vaccination when I was little, and
Yeah.
it's like a big old, it's still got
You
scars
don't
on it.
remember it?
I was little.
Yeah, it's terrible. So they
I was probably
stab,
like 3 or 4 when I got that.
they stab you with a needle like I don't know 17 times.
Yeah, you got a scar from yours? I did too.
So and then it becomes a festering wound. Like it is terrible.
Yeah, so when did you get that? I didn't know they were giving them still. Yeah.
I got it in like 2012.
Well, I probably got mine like 60 or 70.
I went overseas a lot.
Okay,
So, and smallpox may or may not be viable other places. So
okay.
you do anthrax, smallpox. a bunch of other stuff.
Okay. Yeah, I usually take everything I can if they coming out.
Yeah. We're doing algebra study lab next. That's right.
Uh-huh.
Is the information you give out in your Monday course, because of my work schedule, is that different than the information you give out on Wednesdays and Fridays?
No, I'm just going through the thing in order. So, every lecture will be different. So
So
like,
every day the lecture's different, but
Mhm.
it's all in the same week, 2 or week 3 or week 4.
but anything you're missing, I'm gonna be recording and sending out the videos for those lectures for y'all, so that y'all got back up.
Okay.
Hey, don't tell me what's gonna happen with this COVID again.
It's a call from 3:30, right?
All right, y'all, any of y'all going to lab? Okay, so, all right, I'll, reconnect over there for y'all online, okay?
Is it okay if I call?
Yeah.